Okay, so now we are going to start a mock interview for the post of assistant professor in BPSC in maths stream. So first of all, you tell us about your educational details.
वर्ष 2011 में मैंने 10th KR हाई स्कूल बेतिया पश्चिम चंपारण से उत्तीर्ण की। 2013 में मैंने 12th जवाहर नवोदय विद्यालय कुमारबाग बेतिया से उत्तीर्ण की। 2016 में मैंने मोतीलाल नेहरू कॉलेज दिल्ली विश्वविद्यालय से ग्रेजुएशन उत्तीर्ण किया। 2018 में मैंने जाकिर हुसैन दिल्ली कॉलेज दिल्ली विश्वविद्यालय से मास्टर्स उत्तीर्ण किया। इसके साथ ही मैंने 2 बार नेट एग्जाम, 1 बार गेट एग्जाम और NBHM रिटन एग्जाम भी क्वालिफाई किया हूँ। 2019 में मैंने IIT जम्मू में PhD के लिए इनरोल किया, जहाँ पे मैंने अपनी कोर्स वर्क IIT दिल्ली से पूरी की। विगत 2 वर्षों से मैं IIT जम्मू के B.Tech एवं M.Tech स्टूडेंट्स की ट्यूटोरियल क्लास लेता हूँ। इसके साथ ही यदि सुपरवाइजर के द्वारा मुझे कोई एक्स्ट्रा क्लास असाइन की जाती है, मैं वो भी पूरी करता हूँ। एवं वर्तमान में मेरी स्ट्रेंथ लिमिट, कंटिन्यूटी, डिफरेंशियबिलिटी एवं डायरेक्शनल डेरिवेटिव में है।
ओके, तो आप हमें कंटिन्यूटी पढ़ा सकते हैं अभी?
ऑफ कोर्स सर।
जी।
Should I share my screen?
Yes.
Okay. So actually, sir, you need to allow me because you disable screen sharing option.
अलाउ कर दिया आपको?
Okay. So let me write the things. So date is 2nd of March 2023. The topic is continuity. For this, I am following the book Introduction to Real Analysis, which is written by Robert G. Bartlett and Davidson. And this book is of 4th edition. So we will look into this topic, continuity. And for this, I am following Introduction to Real Analysis book, 4th edition, which is written by Robert G. Bartlett. Okay. So before going into the things, so let me ask this question, that is why it is important to discuss continuity. What is the motivation behind it? Okay. So firstly, it was introduced by Sir Isaac Newton and Gottfried Leibniz around 17th century. Then after Karl Weierstrass, he gave the definition of the continuity, which we are following till now. Okay. So let me ask the first question, that is why it is important to define the continuity. Suppose let me take some natural example. Suppose a train is running on the track. So this is a train, okay, which is running on the track, and suppose there is a damaged railway track, that is so there is a damaged railway track. So what will be the obvious expectation from our side? That is, this train cannot pass this point. So it has some limit. Then after, he will call some mechanic and he will fix this problem. Then after, train will pass through this railway track. So this one is getting some motivation. So from here we can get some motivation. That is, suppose we have some curve. Okay. So suppose we have some curve, and at some point we have some problem. That is, it is approaching. So let me define this one. That is
Okay.
as x is
So
approaching
we
to
have
x naught.
discontinuity of first kind, discontinuity of second kind. Can you differentiate?
Discontinuity of
First kind, discontinuity of second kind.
so sorry sir, right now I'm unable to recall the things. I studied this one. Discontinuity of first kind, discontinuity of second.
Okay.
Sorry,
What
sir,
is
I
singular
forgot this
point?
one. Singular point. Okay. So singular point are those points where the function cannot be defined, but f is a function, and suppose it has some singularity at z naught. F has singularity at z naught. So singular points are those points where function value cannot be defined. So either it can tend to infinity, or it can have some real value.
Means?
Okay. So
have
there
you
are
heard
three
about
types.
singular point?
Yes, sir. In the complex analysis, I heard about this thing.
Complex में सुना है तो बताओ क्या होता है singular point?
For example, if I'm talking about 1 by z, the 1 by z has a singularity at z equal to 0. That is, we cannot find the limit
तो
as z
डिफाइन
tending
कैसे
to 0.
करेंगे? सिंगुलर पॉइंट की डेफिनेशन बताओ.
Okay, sir. So singular. Yeah. So sorry, sir. Right now I forgot this thing.
ओके. अच्छा, एक फंक्शन लिखो.
Okay. Yes, sir.
विजिबल है?
Function f.
या fx इक्वल टू
Okay.
x sin 1 upon x. Okay, when x not equal to 0, and 0 when x equal to 0.
Yes, sir.
So tell us about continuity of this function.
Yeah, this function is continuous at x equal to 0. The main property we can use is that sandwich theorem. That is, this function can be dominated by this x, in fact mod x, and as x tending to 0, so this will go to 0.
You are
and
proving
this
it
will...
using sandwich theorem.
Yes, sir.
So
Yeah.
how is it proving? Yes.
Okay, so actually proof of sandwich theorem is very simple. That is, suppose if I am taking any two functions fx, which is bounded by gx and hx, okay, and suppose limit at some point, limit x tending to c hx is equals to limit x tending to c of gx, say it is equal to L. Then from using the sandwich, we can conclude.
But why did you
that
take
is
modulus? I did not write modulus.
okay. So actually the main thing is that if suppose my modulus function, if mod of f is tending to 0, this implies f is tending to 0 if and only. At some point, so as x tending to c. So that's why if this modulus is tending to 0, implies that x sin 1 by x will also tend to 0.
Okay. ये बताओ,
Yes.
क्रिटिकल पॉइंट को डिफाइन करो. क्रिटिकल पॉइंट ऑफ फंक्शन क्या होता है?
Okay. Critical point for any function f. So critical points are those points where either the function cannot be differentiated or it has a slope which is parallel to the x-axis. So those points are critical points. Basically, at these points, we have some relative extrema. It may be possible there will be some relative extrema. Need not be always true, that is, there will be always a relative extrema, but it might be possible there will be some relative extrema.
Okay. And what is stationary point?
Okay, so stationary points are those points where the derivative is equals to 0. That is, we are getting some horizontal tangent lines. at the point. So this, in this case, x naught is called our stationary point for the given function f.
Okay. Do you know about D'Alembert's test?
Okay. So yeah, so D'Alembert ratio test. It is basically defined for the sequence of functions, that is limit n tending to infinity an plus 1 modulus of an is equals to L. Suppose this limit exists and it is L. So if my L is lying between 0 to 1, so we can say this sequence an is converging to 0. And if my L is equal to 1, we, in this case, we cannot conclude anything. Either this sequence may converge or it may diverge. And if L is greater than equal, L is greater than 1, in this case sequence is divergent.
Okay. And do you know P series?
Okay, so P series test is basically, it is defined for the series, that is here, and n is running from 1 to infinity. So this series converges when P is greater than 1, and if my P is less than or equal to 1, in this case this series is diverging.
When P equal to 1 also, then also it diverges.
Of course, sir. That is, series 1 by n diverges. And the reason behind this is this series is not bounded.
Okay. Kanchan ma'am, you can ask.
You are preparing for real analysis.
Yes, ma'am.
Hello.
Yes, ma'am.
Okay. So what are you like preparing? What exactly you will tell? Which
So,
topics you have covered in real analysis?
okay, so in real analysis, I covered limit, continuity,
Hmm.
differentiability.
Hmm.
Yeah, these topics. And if you go for multivariable, in multivariable calculus, like I can cover directional derivative also,
Okay.
differentiability also.
So like if you have said multivariable, so like the function of two variable,
Okay.
like f x comma y, what does it signifies?
Okay. So basically,
If I say
fx,
z is equals to fx comma y, so it is a two variable function.
yes.
So what does this signify?
So for example, let me take z equal to x square plus y square. So this
Hmm.
represents a parabola. So basically it represents some surfaces in x, y, z coordinate. So
Okay, so it's a
let me call this
surface.
is x, y. Yes, sir.
Hmm.
Yes, ma'am.
Hmm.
So this
And
is
what
a,
are the
like,
directional derivative? How will you
okay,
like if you have to just represent through the graph?
okay.
Like okay, so what is our derivative in term in one variable?
Derivative in one variable.
In one variable, yeah.
Okay.
What is the
So
meaning of
basically,
derivative in one variable?
okay, okay,
Like z is
okay.
equals to f of
Yes,
x.
yes, yes, ma'am. Suppose I have a curve like this, okay, and I want to
Hmm.
find the derivative at this point. So
Hmm.
basically, derivative represents the rate of change of this tangent. That is how it is. I'm getting a tangent line. So this
So you used to
tangent
say
line
at
is called,
hmm,
yeah, at x naught. So basically,
hmm,
this tangent line is called our derivative of f at x naught. Suppose this is the graph of some function fx. So let
hmm,
me call it here. It is taking f of x naught, and here it
hmm,
is taking f of x1, f of x2, then f of
hmm, hmm.
x3. So I'm taking these differences. That is f of x1 minus f of x naught divided by x1 minus x naught, and taking
Okay.
this x1 close to x naught. Okay, so I'm taking this difference of this chord, and then taking it's
So what does this signify? I like by calculation or by this thing, it is
hmm.
fine. But graphically, what does this say exactly?
So graphically it represents a tangent line. That is, at this point we will get some tangent
Or
line.
the slope of the tangent line.
Yeah,
What
slope of
the,
the tangent line. Yes, yes, yes.
है ना? There is
Slope
a
of the
difference,
tangent
na?
line.
Okay.
Okay.
So this is in case of one variable. How will you define in
Yeah,
case of two
difference.
variable? Because you talk about multi like this directional derivative.
Of course, ma'am. So okay, so okay, okay. So let me put some graph. Okay, and this is my point. Okay.
First, tell
So
me what are
at
you telling? Like, what do you want to say? First, tell
okay.
me.
Okay. So basically, in two variable case, there are infinitely many tangent lines along this at this point x naught. Okay. So
Okay.
since we have infinitely many tangent lines, so we are taking some particular tangent line. So that's why it motivates us to define the directional derivative of the given function along some direction vector. That is, we have some unit vector u, and along this vector, we are interested to find this rate of change of this given function f.
So you
Okay.
are saying like if you are like if you define derivative in one variable, so directional derivative is a two variable case. You are saying this thing.
Yes, ma'am. Yes, ma'am.
So what
Not
is the
in
meaning
only
of
in two
partial
variable.
derivative? So what is
Okay.
partial derivatives then?
Okay, so partial derivative is an special case when I'm taking this direction, that is direction along x-axis or direction along y-axis.
Okay.
So in this
So
case,
what
we are
does it
getting
signify? Like, okay, that exactly I want to say. Like, if I'll say f of x, like partial derivative
okay.
with respect to x. So tell me
Yes.
graphically.
Okay, so
Take any
graphically,
take
it
any surface, take any surface and tell me what it is. For suppose
okay.
I'm taking a function f and I want to find the derivative fx at point a comma b. The derivative f f is a two variable function. Z is equals to f of x
Okay.
comma y. Now I want to
Yes,
find the
ma'am.
derivative, partial derivative of f with respect to x at point a comma b.
So basically, it is defined as limit t tending to
No, I'm
zero f
I
of.
just don't want to
Okay.
define. I just want to ask how will you just as in one variable case you told me like it's a tangent, it's a slope of the tangent line at that point. What
Yes,
does it
ma'am.
signify in two variable? Because
Yeah.
if you will say two variable case, they will ask these kind of questions only. They will not
Okay.
ask the definitions.
Okay. Okay. So basically, what I feel along x-axis, I will
Hmm.
look into the rate of change of the slope.
No. Rate of change is one thing, but how does
Okay.
this fx, yeah, df by del f by del x at a
Hmm.
comma b, what does it signifies? Like how will you represent it in the 3D graph, 3D plane?
Yeah. Okay. So sorry, ma'am. I right now I'm unable to recall what
Actually, you
what
have to
I think.
fix the surface first, like because you are taking the derivative with respect to x. So here the changing variable is just x. Y is not changing. So in the graph, like in the z is equals to f of x comma y, if you represent any surface, you have to cut
Okay.
the surface with another plane y is equals to b.
Okay.
So the intersection of y is equals to b and this is the section it's a 2D plane. Okay,
Okay.
so from in that 2D plane at point a comma b you can find the tangent.
Okay. Okay.
So here like if you cut by the plane y is equals to b by that surface you will get a
Mm-hmm.
surface which is like 2D plane you will get na.
Mm-hmm. So
So in
basically,
that
we will
2D,
get some line or some curve.
yeah, exactly, line or a curve, yeah, exactly, we will get a curve. So at that curve we can, at that point a comma b I can find the tangent plane and then find the slope of that. So that exactly signifies the like this partial derivative.
Yes. Yes. Yeah, I got it. Shravan.
Okay, okay. And okay, so what is the difference between uniform continuity and continuity?
Okay. So before going into this difference, so
I just
we,
want to
we
ask like just a major difference. Tell me if you know.
okay. So the major difference between continuity and uniform continuity is that,
Hmm.
so here our delta is depending on x and epsilon, but in
Hmm.
uniform continuity, same delta will work for the given epsilon. There is no impact of the point. And also, uniform continuity is defined over some set, and it is defined at some point. Then we are going to the set. So the main difference is that it delta is depending on the point and also on the given epsilon. For example, if I will say fx is equal to
Hmm.
1 by x, okay.
Hmm.
So
Hmm.
if I'm taking some epsilon neighborhood of the point, okay,
Hmm.
So this is the epsilon neighborhood. So for this epsilon, I'm getting this delta neighborhood. Am I right? But if I'm moving something ahead, so for the same epsilon neighborhood, our delta neighborhood will increase. Our delta neighborhood will be less. Sorry. Are you getting? That is, we have some smaller delta neighborhood. Earlier, we have some larger delta neighborhood. So why these things are happening? Because of we are changing our point also. Okay. But in uniform
Give me an
continuity,
example where
this
uniform continuity will work.
okay. So there are infinitely many examples. One can take a constant function. One can take some linear function that is fx is equal to mx or x. Okay. There
If I'll
are
take
some other.
fx equals to x square.
Okay. So if I'm looking into x square, so firstly I need to define the domain. That is, what is my domain? If my domain is something bounded, then in that case fx is equal to x square will be uniform continuous. But if my domain is unbounded, then it cannot be uniform continuous.
Why it is happening? Can
Okay.
you tell me?
Okay, so there are two reasons. For example, suppose if I'm taking my domain like 0, infinity, which is unbounded, and in this neighborhood, if I'm considering okay, so if I'm considering xn is equals to root n and xn plus 1 is equals to root n plus 1. So if I'm looking to their difference, xn plus 1 minus xn, so this difference is tending to 0, but the correspondingly fxn plus 1 minus fxn is not tending to 0. It is going to be 1. So there is one more property, that is if we have some two sequence which are converging, okay, but the output is not converging. So in that way we can say interpret that is given function is not going to be a uniform continuous. And one more thing, these points are also in A. Okay.
Okay.
So because of
And
unboundedness, we are getting such type of things.
okay. And what can you tell about the monotonic function and their point of discontinuity, set of discontinuities, monotonic
Okay,
functions?
yes, sir. So by graphically, if I will tell, so suppose we have a monotonically function, it means that it is monotony. It means that either it will increasing or it will be decreasing function. For simplicity, or it might be constant function, but constant functions can be considered as
No, I'm
increasing or
asking about the
decreasing.
continuity and discontinuity.
Okay, so yeah, so if I'm taking increasing function, so there will be only jump discontinuity type thing.
Okay. So
Yeah.
what exactly you wanted to say? What about the
So
set of
basically,
discontinuity?
so in this case, the set of discontinuities will be at most it will be countable.
Okay, it can't be uncountable.
Yeah.
What do you think? What can be the reason?
The main reason is that we have since it is a monotonic function. So after this point, if I wish to create some discontinuity, so the only possible way is to just going upward. Yeah. Or suppose it is decreasing, so going downward. And then after again we have some continuity things.
Okay, fine. Good. Okay, sir. Fine.
Okay, Parvinder sir.
हाँ जी कुमार,
Yes.
आप oscillatory function बताएंगे? What is oscillatory function?
Okay, so oscillatory function is basically it oscillates between the given two values. For example, sin x. So this is an oscillatory function which is oscillating between 1 to -1. Or for example, if I'm taking -1 raised to power n, this is a sequence. So which is oscillating between 1 and -1. So oscillatory function can be defined which oscillates between some given set of values.
Okay. And what about De Morgan test?
De Morgan?
How to check De Morgan test and Bertrand test? De Morgan and Bertrand test for convergence.
Sir. Right now, sir, I don't know this.
Can you write the second order partial differential equation? Second order
partial differential
equation.
Second order partial differential equation.
Second order linear partial differential equation.
Okay, so linear second order partial differential equation. Fine. Okay. So the general form of a
General form.
so how many variables are there? N variables are?
Two variables.
Okay, so in two variables, in fact I can define for n variables also if you wish. So let me define. So it will have something of this form: f of ux uy, uxx, uxy, and u of yy is equals to so one more point, u will be there, so equal to 0. So in this way we can define the second order partial differential. So for the linear case, okay, so this is the general form of second order partial differential equation, where f is a function of this variable, so at least one ux or uxy or uy will come. But for the linear, we have of this form, that is uxx a of x comma y plus b of x comma y uxy plus c of x comma y uyy and plus d of x comma y ux plus e of x comma y u of y plus f of x comma y of u and plus function of xy, and this is equals to 0. So we are calling this one as a second order linear partial differential equation in xy variable.
Okay. How to check this is elliptic?
Okay.
What is the condition?
So the way, okay, yeah. So if let me compute this p square minus 4 times sc, and if this quantity is less than 0, okay, then we can say the given partial differential equation is elliptic in some domain t. Means it is a function of xy. So these xy's are coming from some domain. So if suppose b square minus 4ac is less than 0 for every xy belonging to D, then we can say the given partial differential equation is elliptic in this domain D.
Okay. Write the one-dimensional wave equation.
Okay, so one-dimensional wave equation is basically utt minus c square uxx equal to 0.
Okay. Whenever you solve this equation, there are three conditions, three kinds of values of u and v constants. Then why we use only one condition before boundary condition? When you solve this equation,
yeah,
then there are three kind of roots we have to find out. Either iota, imaginary exponential form, or sine form, cosine form.
Yeah, of course, sir. So basically we are solving this one using some eigenvalue of thing, that is we are considering characteristic equation or something like this one, x double dash. So firstly we are taking some solution of this form, u of x comma u of t comma x is of this form t comma t x of x, and then we are taking the difference and putting into here. So we will get some equation that is x double dash minus c square lambda times x is equals to 0, and from here we are getting the things. Am I right? That is, we will get some value of lambda, that is for positive lambda, for negative lambda, or for like this. Okay, yeah.
Then why you only condition one condition is? Why not all three conditions or all three conditions, or we have to use only one condition?
We have used only which one?
Which one's either sine cos, not exponential.
Okay. So actually this condition can be other condition can be discarded because of this given boundary condition and initial condition, that is, suppose it has some boundary value 0, that is u at t comma 0 and u at 0. Initially it has position, it is equals to, and u at 0. Initially it had some at L equal to. So we have initially and the final position has some value 0 because of those conditions, that is exponential function cannot be 0. So these are the reasons.
Okay, Kumar, please write Helmholtz equation.
Okay, yeah, sorry sir, I Down for this one.
Okay, so
because
now we can provide feedback to him. Kanchan ma'am.
I think, sir, he is doing good. Like whatever he is preparing, it's fine, sir.
Okay. परविंदर सर.
हाँ जी सर, ओके है सर। बस इनके जो रियल पे इनका कमांड बहुत बढ़िया है सर, रियल एनालिसिस पे ना वो कमांड। और एक्चुअली थोड़ा एक्सप्लेनेशन में जब प्रॉब्लम करते हैं कि मुझे ये लगता है कि जैसे एक्स्ट्रा एक्सप्लेन कर लेते हैं तो वहां पे ये कंफ्यूज ही हो जाता है। वहां पे मतलब कि आई थिंक जो टीचर चाहता है या जो भी पैनल बैठेगा वो सिर्फ ये पूछेगा टू द पॉइंट आंसर होना चाहिए इनका, ना कि मतलब एक्सप्लेनेशन में ज्यादा चले जाता है। आई थिंक अगर डेफिनेशन पूछे तो ऑन द स्पॉट डेफिनेशन हो।
कुमार, वहां पे टाइम ज्यादा नहीं मिलेगा
जी।
ठीक है, तो आपको एक तो ये डेट और वो सब लिखने की जरूरत नहीं है बोर्ड पे वहां पे ना।
अच्छा
पढ़ाएंगे अगर किस बुक से मैं रेफरेंस ले रहा हूँ वो सब नहीं बताना।
अच्छा अच्छा अच्छा।
सीधा टॉपिक समझाना शुरू करो और समझाओ ऐसे कि सीधा उनके दिमाग में जाए बढ़िया तरीके से। कल भी बताया था, ठीक है ना।
जी
हाँ, और हिंदी बोल रहे हो तुम पूरे इंट्रोडक्शन में, तो समझाने में भी हिंदी में समझाओ फिर।
ओके सर। एक्चुअली सर मतलब मैंने वहाँ पे IIT जम्मू में ना सर मैं ट्यूटोरियल अभी भी लेता ही हूँ। तो क्लासेस में तो मैं इंग्लिश में ही, मतलब क्लासेस पढ़ाने में कोई दिक्कत नहीं होती है। लेकिन जैसे सर कल आपने रिसर्च वगैरह वो पूछे ना, तो फिर मैंने उसको गलत इंटरप्रेट कर दिया, जिस कारण से प्रॉब्लम क्रिएट हो गई। तो इस कारण से अब मैं मतलब प्रैक्टिस कर ही रहा था कि मैं अब हिंदी में कम से कम एटलीस्ट जो रिसर्च वाली बातें हैं
हाँ,
वो उनको अच्छे से
पढ़ाने
समझा
में भी
सकूं।
कुछ
क्योंकि अगर
समझाने
जैसे
में
मैं पहले
हिंदी,
इंग्लिश में,
देखो समझाने में लिखवाने में इंग्लिश, लेकिन समझाते टाइम थोड़ा सा नेचुरल फ्लो लाना जरूरी होता है ना। वहां
ओके
पे अगर वो बोर्ड पे खड़ा करते हैं तो डेमो के लिए,
जी 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 जी
तो मतलब ऐसे तो उनको समझाओ चीजों को कि क्लियर हो बिल्कुल सामने, एकदम
ओके
कॉम्प्लेक्सिटी कम होनी चाहिए। और दूसरा, जैसे एकदम मतलब कि स्टार्टिंग में तो तुमने कई जगह अटके तुम।
जी सर। वो फर्स्ट कंटिन्यूटी, सेकंड डिसकंटिन्यूटी,
हाँ,
सिंगुलैरिटी।
तुम जानते तो हो जंप डिसकंटिन्यूटी के बारे में, तुम खुद ही बता रहे थे अभी कुछ। तो जंप
हाँ वो आप
जंप
जो बोले ना जंप डिसकंटिन्यूटी, वो फर्स्ट काइंड ऑफ डिसकंटिन्यूटी ये सब।
हाँ,
तो
तो ये
वो
रिवाइज
चीजें।
करना। अगर कंटिन्यूटी तुमने पढ़ाने के लिए तुम्हें बोला गया है, तुमने खुद भी टॉपिक प्रिपेयर किया है, तो पूछ सकते हैं ना
हम्म,
बस। और सिंगुलर पॉइंट को पढ़ो, क्या होता है सिंगुलर पॉइंट भी डिफाइन नहीं कर पाए।
जी सर। एक्चुअली सिंगल पॉइंट पढ़ा है सर, लेकिन अभी थोड़ा सा पता नहीं एजिटेशन जैसा हो गया कुछ।
हाँ, तो उसको दूर करो, वापस बैठ के ना एक बार प्रैक्टिस करो घर पे बैठ के, कॉपी पे लिखने की, समझाने की, बोल बोल के। जितना आप करोगे उतना अच्छे तरीके से मामला सही हो जाएगा फिर। नॉलेज है और क्वालिफिकेशन भी अच्छी है, होने के पूरे चांस हैं। ठीक है, बस थोड़ा सा कॉन्फिडेंट रहो और सिंप्लिसिटी के साथ में चीजें मतलब रिवाइज करके वहां पे आंसर करो। और जितने भी टेस्ट हैं ये सब टेस्ट भी पूछ सकते हैं।
ओके
हाँ, तो एक बार सारे टेस्ट को देख लो कि कौन सा टेस्ट क्या करता है। और कभी कोई टेस्ट फेल हो जाता है तो अगला कौन सा लगाते हैं फिर, उस तरीके से भी देख लो।
ओके
ठीक है। और बाकी
ओके
थोड़ा सा बिहार की पॉलिसीज को पढ़ लेना ध्यान से, कोई ना कोई पॉलिसी के बारे में पूछ सकते हैं। और कई बार तो वो
ओके
सिंपल चीजें भी पूछ लेते हैं कि हॉटस्पॉट क्या होता है, वाईफाई के बारे में बताओ, कुछ जनरल अवेयरनेस की चीजें, एटीएम की फुल फॉर्म बताओ। ऐसे भी कुछ पूछ सकते हैं इंटरव्यूज में। तो
ATM का तो सर ऑटोमेटिक टेलर मशीन कुछ ऐसा होता है।
हाँ, तो जो भी है मतलब इन चीजों के बारे में, ब्लूटूथ के बारे में पूछ लेंगे। ठीक है, 5G के बारे में पूछ लेंगे, मतलब जनरल चीजें भी पूछ लेते हैं कई बार वो। और
ओके
तुम मैथमेटिक्स के हो तो तुमसे थोड़ा चांस कम है इन चीजों के ऐसे।
ओके सर।
बट एक कॉमन सेंस उनको चाहिए ना टीचर का, कि
जी
मतलब हाँ, तो उस हिसाब से अपने आप को रेडी रखो।
ओके
ओके।
जी
बिहार के बच्चों को पढ़ा पाओगे कि नहीं पढ़ाओगे, उनको ये चाहिए ना मेन तो।
जी।
हाँ, तो
तो
तुम्हारे
मैं
फेवर
बिहार
में
से
चीजें
तो
हैं। हाँ, फेवर
बिहार
में
से
है
हूँ सर,
तुम्हारे।
तो इस कारण से पढ़ा तो जरूर चाहूंगा। वो तो ड्रीम
बिल्कुल
जॉब
बिल्कुल।
ही मतलब
तो
एक तरह
वहां
से
उनको
है।
शो करना है ये बस। ठीक है, कॉन्फिडेंट रहना, हो जाएगा तुम्हारा, मतलब तुम्हारे फेवर में है कई चीजें, तो चांस है, बस आराम से करके जाओ तैयारी।
जी
ठीक है,
जी।
चलो ओके, ऑल द बेस्ट।
सर कुछ चीजें पूछनी थी। पहले तो